Greetings, my name is Steve Johnson. I work for the Serve Center out of UNC Greensboro, and I'm proud to be leading the Building Engineers in K-5 Classrooms initiative here in North Carolina. This video is meant for K-5 teachers that are just getting started with the engineering design process, and it's going to go through the process itself, each step, and kind of give an introduction and best practices to get started in the classroom. So, without further ado, let's get started. So here is the engineering design process that we're using for the initiative. As you can see, there are 5 separate steps. Ask, imagine, plan, create, and improve. In this video, we're going to talk about each step and how to get started and really get the best practices for each of those in your classroom. To give you a little bit more information on the engineering design process, these are engineering lessons and activities that are aligned to content standards. That's very important. This is not something extra. This is all done in group work, small groups and partners. So groups of 2 to 4 are ideal for this. This is not done individually. It's meant for students to be able to talk through challenging tasks. And you want to make sure those tasks are challenging because one of the major points of this process in the classroom is to bake failure directly into your lessons. And so as your students are trying to accomplish the task, you want them to fail as a group so that they can learn how to overcome those failures productively within your classroom. A large blend of tools can be used for this process. Robotics and programming lend itself very naturally to that, but if you don't have robotics and a chance to do programming with your students, you can also use traditional supplies like cardboard, duct tape, pipe cleaners, popsicle sticks, etc. Or you can blend those tools together as you go. A lot of autonomy with materials and resources. Also, it targets our standards very well. So our digital learning competency standards, our ISTE student standards, which are adopted for North Carolina, especially that innovative designer strand, our NC K-12 computer science standards, and especially our North Carolina standard course of study. All of these activities should be embedded with our content that is being taught in our classrooms. So, why should we be doing the engineering design process? What have we seen as a result of this? And so one thing that we've talked about a lot over the years is having all graduates to have certain skills whenever they leave us as a school system. We want them to be able to collaborate effectively with peers to solve problems. It's a major goal that employers want to see our graduates have. A major skill is to be able to collaborate effectively with their peers and solve problems with them. We want our students to understand that failure is a natural part of growing, learning, and problem solving. So there's that growth mindset. We want to make sure that we do that with our students and we develop our students to see failure as a stepping stone towards success. And finally, we want all of our students, all students, to know that they can be successful in much needed STEM careers. Now, if those are truly what we want our graduates to have as a part of their journey through our schools, then we have got to start this work in grades K through 5. That's why this initiative is so targeted through grades K through 5, is to get these skills early for our students so they can see themselves in these careers and see themselves as successful with these skills that they can then maximize that success in grades 6 through 12 and beyond. Now, why use the engineering design process to make that happen? There are a lot of different ways to get to these skills in the classroom, and they're all valuable. There are things that are great that our teachers are using. But what we've seen with the engineering design process is that it's been a catalyst for change for teachers to really get to these skills practically. And that's the reason why this process works so well, is that it is the one that is the most easiest and the most practical for our classroom teachers to actually make these skills happen in their classroom. So why? The first reason is that these are activities and lessons. These are not long units. These are not long projects. This is not necessarily to bring the community in and have a big long project. It's a short and sweet activity that's very targeted to content standards. And that's important as well. It's not one more thing for teachers. These are just a different way to teach the standards that we are already teaching in our classrooms and in our pacing guides. And finally, it allows a ton of teacher autonomy whenever you get started with this. So you'll have your professional judgment on the groupings in your room, the constraints you want to use for the tasks, the materials, the amount of time you want to dedicate to it, the frequency, how often you do these activities in your classroom. All completely up to the teacher whenever you get this started. So these are some reasons that have shown to be why this has been a real success for our classrooms across the state. And now we're going to walk through the process step by step to kind of get a feel for how you can get started with it in your classroom. All right, so the way we're going to introduce the process step by step is by doing it in a bit of a parallel. I'll talk about each step of the process and kind of describe best practices and introduce you to each step and how to get started. And at the same time, I'll be bringing in examples from this great lesson that Kim Colazzo did that revolves around Iggy Peck Architect. Now, Kim Colazzo is a great STEM teacher here in North Carolina, and so the lesson idea that I'm going to be sharing with you is one pulled directly from her classroom, her STEM lab. And if you don't follow Kim, make sure you do at K Colazzo. So let's get started. Of course, the very first step is the ask stage. This is the very first stage of the process. So in the ask stage, it's very important that you present the task simply and have students generate the questions. And so all you're doing is laying the task out to the students and having them generate each of the questions that they need to ask in order to better understand this step. Now try not to give away too much with your answers. Let them get to be better questioners. So for example, they will be asking questions about how much time do I have? How many partners will I have for this task? They'll ask about their materials, what kind of materials they can use. They will ask some really great questions. They'll even ask questions that you may not have anticipated and that you'll have to answer on the fly, which is part of the fun of the process. But in your answers, make sure you're not as helpful in giving away too much. Let them probe the task rather than giving them too much at a time. Another big good best practice for this step is to not give the materials out yet. So don't put the materials out that they'll be working out because students and really adults and all humans will jump straight to that create phase of the process if they have their hands on the materials and they can grab at them. So don't put the materials out until you're ready. Another thing you need to make sure of is sometimes you'll need to guide the students to the right kinds of questions. For example, if you're doing a task that has a time limit on it, like a 2-minute time limit, that's a very important piece of information that they need to know in order to plan properly. And so you may need to guide them toward that right type of question, just to make sure they understand fully the task at hand. But the more you do it, the better the questions they'll ask. And oftentimes, they'll ask things that you didn't even anticipate, as I said before. So the example here in this ask stage, real simple. The ask for Iggy Peck Architect, after reading through that book, the ask stage is, can your team build the tallest freestanding tower that will support the weight of your rock? And so that is the ask that you present students with, and from there, they generate all the questions. In this example, she also used a pumpkin. I believe it was, around Halloween. So you can use different rocks, pumpkins. Like I say, the materials can be very, depending on what you have on hand, is what they'll be supporting with their tower. So in this example, you present that ask question to the students, and they would ask a lot of questions. So they would ask about what kind of materials can I use with this process? How long do we have to do? Can you build it on a flat surface? Can you use a wall as part of your tower? When you say tower, does the rock have to be at the top? Can it be in the middle? These are all questions that you want them to ask to better understand the task as you go. And as a teacher, you have autonomy to determine the answers to those questions. Depending on how hard you want it to be, the answer to that question, where does the rock have to be? Does it have to be at the top? You might say yes, which ratchets up the difficulty pretty well. After students have exhausted the amount of questions that they've asked, now they move on to the imagine stage. And so in this stage, they're simply brainstorming. So in their groups of 2 to 4, they're brainstorming ideas and choosing one best idea. And again, these are groups of 2 to 4. We do suggest that when you first start this process, you might want to start off in partners, just until they get the hang of the process and have a smaller group to hash this out with. Especially younger students, it's great to start with partners. One thing that we also allow in this stage is if they ask, students can feel the materials to get an idea of the size, the weight. For example, we talk about Iggy Peck Architect. If you're doing a rock, in this stage, you might let them feel the rocks so they can get an idea of the weight of the material, so that when they get to the plan stage, they can do a better plan and brainstorm a better idea in this stage. Another piece to really think about here is that they have to come to consensus on their first solution. So this can often be the most difficult part when students first do this, is when they're brainstorming as a group, they have to come to consensus on their first try, their first attempt. And so some strategies that can help, obviously, if you've done rock, paper, scissors, to kind of choose between ideas within the group. Another great thing that students do a lot is they learn to merge different ideas into one. And so if you've got a couple kids that are strong-headed in a group and they have a different idea that they're uh, really passionate about, they can bring those ideas and put them into one and kind of meld those ideas together. And again, that's a critical part of this process. We want to put students in that situation to be forced to agree and to come to consensus on an idea that they want to try. Those are part of the skills we're teaching to our kids within this process. Now, in the material stage, so as we get through this stage so they can imagine and make a better plan, for the example of Iggy Peck Architect, we tell the students what the materials are. They probably would have already discovered this through their questions, but we make sure we lay it out so that it's extremely clear for them before they get to the planning stage what they have. And in this piece, of this task, the materials that the students were able to use were 15 straws, 24 inches of tape, scissors, and excuse me, their precious rock. And the constraints that were developed for this particular task, and again, the constraints are varied based on the teacher. You can add or change these constraints as you see fit. But for this particular example, it had to be freestanding. So the tower couldn't lean against anything, couldn't be against a wall, had to be freestanding. And the other constraint is they could not add or acquire any additional materials. The materials that they're provided is all you get. That is a major constraint whenever doing this kind of task. And constraints are great to think about for these tasks and to change them up. You can often do the same type of task over and over again by changing the constraints, the materials. You can add a whole other level of difficulty that can throw students for a loop, which again is what you're going for. You're trying to get them to experience that failure and productively work through it. Another great way in this imagine stage is to really use a budget. And so in this example, you've got 15 straws, 24 inches of tape, and scissors. In other ways, you can add a budget to this. So for example, if you're working on two-digit addition, you could have each straw be worth $13 or 13. You could have each foot of tape be worth $2.56. You can add a budget to easily target math standards, and that includes not just adding money or just a strict addition. You can use fractions, you can use all types of ratios, you can do all types of things with the math standards that are very easy, and all you got to do is build it in as a budget item so that when students get to their plan stage, they have to budget. They have this amount of money to spend or this amount of whole numbers to spend whenever they go to plan their attack. So, talk about planning. Here we go. So now they've asked their questions, they've brainstormed ideas, they've got a feel of materials, they've come to consensus on a best idea, and now it's time to put that idea into an actual plan. This is a very important step. They should always make a plan before they start creating. The more often they make these plans, the better they get at planning, and the better they get in their designs, the more often they do this. There should be one plan for the group, and they should always make that plan. Now, make sure you let students know a plan is a good, strong first attempt. That's all a good plan is. You go in with a plan of attack, and as things develop or as things change, your plan will probably need to change. And by the time you get done with this, whatever you end up creating to solve the problem might not look anything like your first plan, and that's okay. But they do need to know that they need to have a good plan for the first attempt. That's how they get better at planning as they go. So this is a spot where they can sometimes need to make some hard decisions based on the constraints. For example, a constraint could be a limited amount of materials or a set budget. So as they're planning, they have to determine where to put those items, how to build those constraints into it. As students do this often, you'll see students getting really good at managing this piece of it. For example, they may not use all 24 inches of tape for this particular activity. They may try to use 12 or 16, and that gives them some leeway so that when they actually create this item, they have some backup plans, and they have some materials that they can use to fix things as things go wrong. So as students start doing this, they start thinking very critically like this. As your students and you're walking through this stage and all stages, make sure you're really observing your kids carefully. Um, really encourage students of different talents to try different pieces. Some will be great at drawing out the plan. Some will be very big ideas folks. Some will be just natural engineers. Some will be great at the budget piece. Really focus on what are your students doing and how are they speaking to each other throughout this stage. These are just some examples of our Iggy Peck Architect students designing their plans. You can see that they've got their pencils out, they've got some materials there, they're really looking carefully, they're really trying to measure and think through how are they going to make this happen, and they're drawing their diagrams. Again, that's an essential part of this piece, is really drawing out and thinking through your plan before you get started. Now, on to the create stage. So now they've asked their questions, they've brainstormed their idea, they've come up with a good plan of a first attempt, and now they're going to see how it goes. So again, as I said in the plan stage, make sure the students start from their plans, but again, they don't have to stick to them once they start to fail. Now, as you are watching this stage, again, these are designed to fail. So as students are creating their plan, they're going to find out that there are weak points in the plan, that the structure, in this particular example, the structure of the tower, the straws might bend at a certain angle, so if they have a certain length, they might bend, and so they're going to need to rethink how they are putting their straws together and what they're taping together. As you're watching students fail, really value their thinking and their perseverance. Here's a chance in real time to talk about that growth mindset and really value that in your students, and really point that out to the others. As they're doing this create stage, it's a great time to sprinkle great vocabulary as you facilitate. As you're walking around, as they're running into problems, they say, this is the kind of problem a real engineer has to deal with. They have a limited set of materials, they have a limited set of time, they have to make do with what they've got, and they have to come up with the best solution. Or you might point out different students' solutions as you go, and talk specifically about these math terms especially. Don't talk about that's a really good support system. Talk about why it's a good support system. Point out the angles, the degrees, what kind of shapes that they're making in this particular example. And then give them some ideas of how they can think through and make it stronger or better as you go around and facilitate this stage. Another thing to make sure you remember is to resist the temptation to help too much. You want them to struggle productively. And as your students are doing this and working through these tasks, you'll see them struggle. And that's a good thing. It's a good thing to see them struggle and to give them support through that struggle. So facilitate them towards trying new things and trying new ideas that can help them discover ways to improve their solutions. And last but not least, celebrate the failures. If you have some spectacular failures, really identify those students and say, boy, that was a really great thinking, and talk to me about why that didn't work. Why did it not work? What did we not think of? And then celebrate that as a class. And just some quick examples. This was the first. The students here are doing it with pumpkins. This is also something that Kim and I did as a workshop for NC Ties, and so we did it with rocks. And you can see this is fun to do with students, but it's a great way to introduce this process to teachers as well. And so I just thought I'd throw some examples of some of the creations that our students were making and some of our teachers were making in this particular activity with Iggy Peck Architect. Last but not least, let's talk about the improve stage. So a lot of times what you'll get into is this rapid prototyping part of the process. So what that basically means is as students are creating and they're failing, they're going to be improving as they go. So they're going to get a kind of a mini stage within the process. Build, fail, fix, build, fail, fix, and back and forth until you're done with your time. This is often the stage that honestly is the most chaotic of all the steps because you're likely pressed for time, cleaning up materials, the class period is ending, you got to make room for the next subject, or they got to go to specials, but make sure you make time for this improved stage. Even if you run out of time in the class activity, try to circle back to it later in the day or later in the week and really talk about this, because it's really important for them to think through this. Make sure students can share their prototypes, and so they can share what others can do. And so what's really great about this process is every group will do something differently, sometimes drastically different. And so there's value in sharing that creativity out with each other. Also, don't let the same kids dominate the conversation. So as you are observing, really seek out those quieter students, and try to pull it out from them, their thinking and their knowledge. And they are going to surprise you with how much they're thinking through these tasks. And again, a great process here. It's time to really heap praise on the process rather than the success. So the process they went through, how they thought through problems, even if they never finished the task or they didn't build it correctly, really give value to that process. These are the questions that Kim suggests at the end of this particular task, and these are great questions just in general to ask students in this improve stage, either to ask each other or ask as a group. What went well, what made it challenging, what would you do differently next time? If you could choose different characteristics, what would you look for? Things that you would change. And so this is just a great set of questions just in general when you get to this improve stage with your students. So there it is again, the engineering design process, all 5 stages. We've now talked through and introduced each of those stages and how to get started in the classroom, and I hope you found that valuable. Before we go, I do want to offer a couple of just final reflections as we go, just to kind of leave off with this video. So as you guys get started in your classroom, one very important thing to do is to really observe your students as you're doing this process and look for new leaders emerging in your classroom. A lot of times our traditionally marginalized students, the students that don't necessarily do great on their reading and math tests or are in the highest reading groups, a lot of those students do really well with this process and really become leaders in the classroom. And so capitalize on that, recognize them for that, and allow that leadership to really show and really pump those kids up through this process. Another thing you want to make sure to do is check out the free activities on GoOpenNC. So there's a group, Building Engineers in K-5 Classrooms, that includes introductory lessons. It also includes a bunch of activities, that engineering design activities broken down by grade level and all created by North Carolina educators tied to North Carolina standards. I'll be putting a link to those into the description of the video, so make sure you check those out. Remember to keep at it. The more you and your students use this process, the better it gets, the easier it gets at the work on this. So when you first start, you may have some students that don't handle the collaboration very well. They butt heads when they get together. Some of them may be very dominating. So that's the entire point of the process, is to make sure that those kids have a chance to collaborate and work with others creatively and constructively. And so keep doing it. I promise, the more you do it, the easier it gets and the more problem solving you'll see in your classroom. Also, make sure you expand these lessons so your students are going to be very motivated and engaged. So capitalize on that. Create writing prompts after these. Get them to write about what they've done. Get them to research or read more about these different types of tasks and different types of activities that you're bringing to them. And finally, have a lot of fun with it. Just have a lot of fun in the classroom. This process is a lot of fun with kids. It's building, it's falling, it's creating, it's improving, it's making it better. And it's just a lot of fun for kids to do. And I want you to have fun with it as well. Bring that joy into your classroom as you're doing this process with kids. Last but not least, if you want to learn more, make sure you go to k5engineers.org. All the information about the initiative, all the links, all the professional development, all that information is on k5engineers.org, and it's free for anyone across the state of North Carolina. So go on, have fun, and do a great job of getting that engineering design process working with your students, and let us know if you need any help.